Okay, so our part 3 for the week 6 lecture is going to be about design for manufacturing and assembly, or known as a DFMA. So we start with the session, okay, design, manufacturing, and assembly. First, we need to understand what is the DFM. So we said that DFM is the most common one is the DFX, design for manufacturing, which can be mainly including everything. DFM is a development practice emphasizing the manufacturing issues throughout the product development process. The successful DFM results in lower production costs without sacrificing the product quality. So mainly we can do that by reducing the component cost, reduce the assembly cost, and reduce the production support cost. Now, even if we're going to change the material, for example, again to use the cassette part from aluminium or is going to be much lower cost than if I'm going to use the steel or the iron. First, the weight is going to be different. The energy required to do the manufacture is going to be higher. If I'm going to make multiple parts and then I'm going to assemble them, if I'm going to redesign the things to be made as one part, of course, I'm going to reduce the assembly cost. Even if we're going to make the assembly much easier by reducing the number of the bolts to hold the parts together, this will reduce the assembly cost. Using the bolts is going to be less cost uh, than the welding, for example. Same thing, reducing the production support cost. So we have support costs as well, like, for example, something like they call it the dark factory. That's something that you will hear about it in the near future, which is how the factories can work at night without turning on the lights, because saving the lights is going to be something like saving the energy and then saving the cost. And that's happening when, for example, that the whole factory is going to be 100 run without the human interference. So in general, the DFM is the optimization of the manufacturing processes for the product. So design for manufacturing as a goal, the goal is to design a product that is going to be easily and economically manufactured. The importance of DFM is underlined by the fact that 70% of manufacturing costs of the products is going to be cost of the materials, processing, and the assembly are going to be determined by the design decision, while the production decisions, such as the process planning or the machine tool selection, are going to be responsible for only 20%. So the design is going to be something like 70 to 80% of the cost decision, and manufacturing anything between 20 to 30%. In general, DFM is much more than a cost reduction. It is a design strategy that requires an expertise of multiple team members and the use of the basic design rules, guidelines, and the cost models. DFM often going to result in a significant cost reduction as well as an improvement of the product quality and the development of the cross-functional expertise within the organization. DFM is a tool used to select the most cost-effective material and the process to be used in the production and in the early stages of the product design. Some of the DFM example is going to be the GM 3.8 liter V6 engine. If I'm not going to talk about the whole engine, we're going to talk mainly about the manifold. So you can see this part here, the intake, the air intake for the manifold. You can see that this one is actually made of plastic. So you will see that the original and redesigned air intake manifolds for the GM 3.8 liter for the V6 engine, the first one was made of aluminum, and then they made it as a polymer plastic one. So definitely you will know that this one is going to be done by well, let's say it's going to be done by the injection molding for the aluminum, or we call it the die casting, while this one is going to be for the plastic injection molding. So you can see even the design difference is going to be that this one is going to have an extra part, okay, extra part has been added. Like for example, the sensors setting and the extension for the manhole manifold here actually make it more complicated than the previous one. This definitely was a part of the design, but it was individual part to be assembled here. And thus, by joining the two parts together, we not only reduce the cost of manufacturing between the plastic and the aluminum, but also we reduce the weight because the different materials have different properties, like the lighter material is going to be much better for the performance of the car in general. And in addition, the energy has been used to manufacture the plastic was less, and we joined the two parts together to reduce the cost of the assembly. So we're coming now to design for the assembly, which is a method of design of the products for ease of assembly. DFA is a tool used to assist the design teams to design a product which transits to production at a minimum cost by focusing on, first, the reduction of number of the parts, second, reducing the handling time, and also improving the ease of the assembly. So mainly it's going to be the optimization of the part of the system assembly. So you can see the difference between the two photos here. What's happened that earlier we used to have the screws to hold the parts together. We just changed it by snap fit. That's it. So instead of spending some like 10 seconds or 20 seconds trying to put the bolts on, we're only going to push it once and that's it. So the DFA rules, and this example actually a set of the DFA guidelines from the computer manufacturer, is the minimize all the part counts, the encourage all the modular assembly, stack assemblies, eliminate the adjustments, eliminate the cables, use of the self-fastening parts, and use of the self-locating parts, eliminate the reorientation, facilitate the parts handling, and specify the standard parts. So the design and manufacturing and of manufacturing and assembly can be joined together. It can be merged as a DFMA. So DFM and the DFA can be merged as a DFMA. Let's update the sequence of the engineering design with the DFMA, like the conceptual design, the DFA to optimize the design for the part count and the assembly, while DFM is to optimize the design for the production readiness. Then the detailed design. So the last two parts is going to be the DFMA. An example we have here is for two products going to actually it's same product but with two different designs. So here we have 24 parts, including the bolts and the nuts and the washers, 8 different parts, multiple manufacturing and assembly processes are going to be necessary. And then we can simply just make it as two parts. Two manufacturing process, sheet metal working and the bar making, and one assembly step. Even further, you can do it with the plastic injection molding and you can make it as one part. Just an example. Or I can make it with sheet metal working by, instead of having the handle here, this part can be simply bended here and then just one process of the second process is going to be just hold the part with the bolt or by doing, well, for example, spot welding. So the key DFMA principles are first, the minimize the part counts. That's what we saw in the previous example. Standardize the parts and the materials to reduce the manufacturing processes. Create the modular assemblies designed for the efficient joining. Minimize the reorientation of the parts during the assembly and or the machining. Simplify and reduce the a number of the manufacturing operations, and finally specify the acceptable surface finishing for the functionality. Okay, so that's it. That's what we need to follow to do the DFMA principles. So now we finished the third part, and we go into the fourth part, which is going to be design for the environment.